All right, so hopefully you've given these a try, but in each case we want to do two things. First, tell if it's a permutation or combination. Remember that permutation means that the position matters, and a combination it does not matter. And then secondly, how many possible ways could each of these scenarios happen? So scenario one, 32 people need to take an elevator to the top floor. They will go, in groups of 8, and they're deciding who will take the elevator on its second trip. That information, a lot of math problems, sometimes they give you information that you don't really need or care about. We don't care if it's the second trip or the fifth trip or the 29th trip. It doesn't really matter. We just care that they're going in groups of 8. And so here's a question for you. If I'm one of the people in the groups of 8, let's suppose people get on the elevator in that order that I just wrote, or let's suppose they get on the elevator in that order that I'm writing underneath it. And the question I have for you, is there any difference? And the answer is no. If you are person A, if you're Albert, you get to go on the elevator right here, and so does this last person. So does Harriet, let's say. Can't think of another name that starts with H. In this example, Harriet's getting on the elevator first, and Albert's getting on next to last, but both of them still get to go. So in this case, the position does not matter, and when the position does not matter, that means we're dealing with a combination. Okay, the way that combinations work, and this is how it looks in the calculator, this is the total number of people that you're choosing from, and this is how many you choose. Okay, so the total, and then R represents how many chosen. So there are 32 total people, and we are choosing groups of 8. So we're choosing 8 of them. So whatever that number is in the calculator is going to be our answer, and let's find that right now. So here's how we would do that. We want 32, and then we want to go to math, and then scroll over to probability. Oops, that's not what I meant to do. So again, 32, math, probability, and then what we're looking for is number, at least on mine, it's number 3, NCR. C means combination or choose. So 32 choose 8, it's probably going to be a pretty big number. And let me just move it over so you can see it. It is a big number. It's 100, what is that? 10,518,300. So these numbers tend to be pretty large. Factorials in general are large numbers. All right, scenario 2, 4 out of 16 students will ride in a car instead of a van. So you have 16 people, 4 of them get to ride in a car. So let's say it's A, B, C, D who get chosen, or picked, I should say, or let's say it's D, B, C, A. And the question is there any difference? And it's just like the elevator problem. There is no difference. If A gets chosen first or if A gets chosen last, he still gets to ride in the car. So it's going to be a combination. We have 16 people, and we're choosing 4 of them. So 16 choose 4. And we put that in a calculator. I'm just going to do it. Calculator's acting up, so I'm going to do it off, not on the screen. But if you do 16C4 in the calculator, you end up getting this number right here. It turns out to be 1,820 possibilities. All right, number 3 says the batting order for 7 players on a 9-person team. So it kind of gives it away in the way they ask the question, but does order or position matter? It sure does, because if I'm picking this order, A, B, C, D, E, F, that's 6 letters, 7 letters. If I'm picking this, or let's say I scramble it up and I do it this way instead, this matters a lot because in baseball there's only 3 outs in an inning. So in this scenario, A, B, C get up to bat. In this scenario, A doesn't get to bat if the first 3 guys get out. B and C do, but A is locked in 5th place. So this is a permutation. The order does matter. We have 9 people, and we are picking 7 of them. So if you go to 9 P7 in the calculator, PR, NPR is right above NCR. 9P7, this turns out to be quite a large number, 181,440 ways that you could pick a batting order on a 9-person team. That's pretty amazing to think about, when only 9 people, and yet there's over 100,000 ways you could arrange them. All right, number 4, last one, a team of 11 dodgeball players, so we know it's going to be either 11 choose or 11 pick something, needs to choose a co-captain and a captain. And don't be misled by the word choose. Choose could be, it's another name for select. It doesn't mean that they're telling us it's a combination. And in this case, order does matter. So let's suppose I'm picking Albert and Bernard, or Bernard versus Albert. In this scenario, here's my question for you. In the top scenario, who gets to be the captain? And the answer is, in this scenario, Albert is the captain because he got picked first. In this scenario, Bernard is the captain. So the order definitely matters here. If you get picked first, you get to be the captain. If you get picked second, you're the co-captain. There's definitely a difference. Since the order or position matters, it's pick rather than choose, and it's 11 pick 2. And when you put that in a calculator, there's 110 ways that you can make that happen. So that is the difference between a permutation and a combination. I hope it makes sense to you.